Right, question 9. With 9 here, what we're first going to do, use a graph to estimate a median speed. So, median speed, well, interestingly, it's not gone from 0. So, it's gone all the way at 60, but it started actually at 2. So, 2 to 60, we've got 58 there. So 58 values, add 1 to it and half it. Which will then give us 29.5. So you go across at 29.5. And then come down from where that was at. And we're pretty much there for part A at 120. Part B then says to us the speed limit on this motorway is 130 kilometers per hour. Police traffic said more than 20% of the cars travelling on the motorway break the speed limit. Comment on what they say. So what we've firstly got to do here then is look at 130, go up there and go across. So out of what we have here, what are we then looking to do? Well, we're told here that 8 out of how many cars, because it's 8, 52 take away 60 is your 8. 8 out of your 60 cars, or you can take it as 58, but still get the same answer. So 8 out of 60 as a percentage, divide it and then times it by 100. Actually gives you 13.3%. So police are incorrect. Then we're asked for these 60 cars, the minimum speed was 97 and the maximum speed was 138. Use a cumulative frequency graph and information with straw box plot. So if we've got, and I'm going to try and draw this with straight lines this time. So we've got 87, sorry. There's our 97 point. The maximum then is 138. So we've got those 2 points drawn on. The median we've worked out already, which is 120. So that's nice and straightforward in there. What we're then going to do is work out the interquartile range. So if I've worked out here, this is where the value is that I'm looking to get from there. If I add 1 to that and half that, then that will tell me 15.25, so near enough 15 to be honest. You're going across for your lower quartile. So your lower quartile comes in at 116. So 116 there. Going in there. Once you've got your 116, you then go to the upper quartile, which is 45, and go across again, and come down. And again, your lines will be straighter than mine. That's coming in at 125. And then we create the box. So we've got the box there, and then also, these are sometimes called box and whiskers for the reason of these, calling these the whisker parts. So that's the box plot drawn. Question 10. The table gives information about the weights of 50 suitcases in an airport. Work out an estimate of the mean weight. So, firstly what we're going to do, I'm not going to use the side of the table because we need to use that thing for the histogram. So I'm just going to put down here what we would do. We're going to do the midpoint, and then we're going to create fx. So the midpoint of these values, so 5, middle of these, 12.5, 17.5, and then middle of these two. If you're never sure, you can add the two together and half it, 27.5. We're going to times these midpoints by the frequencies. So 5 times 16 is 80. 17.5 times 18 is 315. Sorry, I can't read my own writing there, can I? That's 12.5. So step 1, make sure you can understand what you've written yourself. So 12.5 times by 18 gives you 225. Then we've got 17.5 times 10. I'm going to put that in a calculator, 175. And then 27.5 times by 6, which gives us 165. 165 plus 175 plus 225 plus 80 is 645. We then divide that by the total here. Now we've already been told it equals 50 in the question. So the mean is then 645 divided by 50, which gives us 12.9 for the mean weight. That's the mean worked out. We then asked passengers have to pay extra money for any suitcase that weighs more than 20 kilograms. Two of the 50 suitcases chosen at random. Work out the probability that both suitcases weigh more than 20 kilograms. Gotta say, quite a tough question this. So it's probability that both are, so 2 are greater than 20. Well, the probability of the first one being greater than 20 is 6 out of 50. Then you then pick one. So there's only 5 of them left, and it's out of 49. So 6 over 50, and then times by 5 over 49. I think I'll just write it in fraction form, which is cancelled down is 3 over 245. And on the grid below, draw a histogram of the table. So here's the histogram. So this is why I've left this spare, so I'm going to put this on this part. Class width is 10, so it's the gap between them. The tricky thing for you guys is to remember the difference between what you're doing for each one of them. We then divide them. There's 1.6. 18 divided by 5 is 3.6. 10 divided by 5 is 2. And 6 divided by 15 is 0.4. So we're going up to 3.6, so I can see each one of these is 1. And then it's the histogram drawing. So the first one is from 0 to 10, and that goes up to 1.6. The second one is from 1 to 15, and that goes up to 3.6. I'm just making sure that I make it as neat as I can. You guys will find this a lot easier with just a pencil and ruler. Then we've got 10 to 15 to 20, which is 2. And then we've got from 20 to 35, which is 0.4, so that's only a small one. And there's the histogram drawn. Question 11. Factory makes 600 laptops. Mrs. Green is responsible for checking these laptops. She's going to make a random sample of 80. Describe a method she could use to select the sample. So, what could we do? I think probably it's got to be a random sample, hasn't it? So I think what I'd say is I'd number each laptop. Put numbers in a bag, and then select, and we need 80 numbers without looking, so it's purely random. B, she finds that 3 out of the 80 laptops are faulty. Work out an estimate for how many for 600. So it's 3 out of 80, that's the proportion of them, times it by 600 will tell me how many you'd expect then out of 600 to be faulty. So 22.5, so you can probably equal to round up to 23 laptops. 10 socks in a drawer, 7 brown, 3 grey, random 2 socks from the drawer at the same time. Complete the tree diagram. So 7 out of 10, 3 out of 10. If you've picked 1 brown, then you've only got 6 brown left out of 9. You've still got 3 grey left, but only out of 9. If you've picked a grey, then you've only got 2 out of 9 left here, and you've still got 7 out of 9 brown. Work out the probability that Bevan takes 2 socks of the same colour. So we've got the probability of brown and brown, and the probability of grey and grey. So brown is 7/10 times 6/9, and grey is 3/10 times by 2/9. So 7 times your 6 is 42/90, and 3 times your 2 is 6/90. Add these two together, so probability of same is equal to 48/70. Over 90 will cancel down. If you divide by 6, or you can divide by 2 and then by 3, to 8/15. You could have left it at 48/90 to be honest and still got full marks. And the final one, question 13. The table shows the population of each 3 villages. Carries out samples in these 3, and she wants to use stratified. 50 people from Brigby in this sample. Work out the number of people from Ireton. So Brigby is 50. So it's 50 out of 370 that have been asked. If you then times that, because that's the proportion, if you then times that by what we're after, Ireton, 127. So 50 divided by 370 times that then by 127, which then gives you 17.162. These two are recurring, so obviously you can't have 17 point something of a person, so that's roughly then equal to 17.